Trend, and today I'm going to talk about my Lab 4 malware. Okay, so I'll talk about my parts and Adam will talk about his part. So, first of all, I did the phase 0 and phase 1. So, yeah, I just extract the instruction file, the GPU patch v4.x, and I also create the user account and the admin account using a command prompt. And yeah, I did take a snapshot about the P1. Okay, now we scroll to phase 2. Phase 2 is mainly I talk about Brockman. I use Brockman, and instead of the system informer, I use task manager to see the process. All right, so what I did in here is, yeah, I created the, so there's two phases. First is I use the Brockman while not creating the file, the L1C2N53 game.dat file. So yeah, that's the first phase that I did. So what happened is the GPU patched the X file. It says name not found because it requires the L1C dat file to be graded. So yes, I manually grade the L1C dat file in the C drive users public directory. So after I grade it, I run the Procmon again. Now we can see that yes, I successfully run the malware. All right, so yeah, that is for the phase 2. Now what I find here is in here, right? I also see the I go to this entry right here. Yes, and I can see that it's talk about the registry key about this. I go to the property to check it more, and we can see that it says the lab analysis stop. That's very important that what we find. All right, so that's not very detailed. Now we're gonna go more detail in the next phase.
So for phase three of the lab, we're mainly focusing on the network communication that's happening. So to use this, we're using tools FakeNet and a bit of Wireshark, but mainly FakeNet. So when we run FakeNet and then execute the malware, it'll give us all the traffic that happened. And as shown in this picture, we can see that what stands out right away is this. There's DNS and HTTP connections, attempt connections, and that start from the process the GPU version 4 exe. And in this we can see that there's a DNS to the domain dangerous.url. We can also see that it's a GET request for payload, and we can see the user agent security lab 1.0. So this just confirms that the malware is trying to get outward network connection. And we can also see that from this Wireshark capture that to that IP found, the 192.0.2.123, there was traffic going on. So from the FakeNet logs, we can assume that there is command and control communication that's trying to be set up by this malware, and that this malware is trying to get this other payload from the server that's being hosted to do probably a staged payload delivery.
All right, so in the phase 4A, I use the API monitor. So over here, yeah, same thing, right? At first, before creating the L1C dat file, right? So I just revert to the P1 snapshot. Now over here again, it just normally says invalid file execution. That's pretty normal. Now, after I create it and I run the API monitor, now that I see there is some win HTTP uh, entry or or application open. So what this saying here is that malware is trying to communicate with the extend domain. Yeah, so right here we can see its reviews through the Win HTTP Connect saying that dangerous.url. So that is the malicious that we can see. All right, so for the 4B now that I use the X64 DBG. So what this does is how I do it. So I open the X file inside this 64 DBG. Yeah, and I go to the symbols, right? And in the symbols, I select the one that has Win HTTP Connect. All right, so I select it and I follow it. So after I follow it, here's what I see: the CPU tab, and then I transfer this to the AS ASI to the U from the ASCII to the language UTF 16LE. Right over here, I can see yes. Now it's revealed showing that the whole URL are https dangerous.url/payload. Right, so it's basically revealing the malicious link URL. All right.
For phase 5, we took a process monitor capture as well as a Wireshark capture and just analyzed the times in it to see what's actually happening as the malware is executed. So for our process monitor, we have this filter that we use so to only look for process name GPU patch version 4. And as well, we just excluded any path that begins with Windows just to only see any suspicious things going on. When looking at the process monitor capture, we can see that there's timestamps for the process start, as well as it shows a bunch of other things like there's threads being created and registries being accessed, as well as files being created and accessed. Though it's also loading some DLLs we can see here. There's a kernel 32 DLL being loaded and some other ones. So there's a bunch of different events going on that just show that what's going on. And if we compare this to the Wireshark capture that was taken at the same time, we can look for when the network communication actually started. So here in the Wireshark capture, we can see this is the first time that there's a outward connection that comes from the malware being executed. It's the DNS query. We can see that the time it happens at, and it's just like zero point 0.1 second after the process starts in the malware. So if we look at the time that the network communication started and compare it to when that is in the process monitor log, we can see that the network communication happens after most of the events have already happened. So a lot of the registry activity and the file activity has already happened, and then there's a short break in it where everything slows down and there's mainly network activity going on in the Wireshark. And then it goes back to doing some more, but most of it happens before the network activity even starts. So based off this, we can most certainly say that the GPU patch version 4 malware is trying to establish communication, likely for C2, and it could also be exfiltrating some of this data that it's getting with the registry queries, because there's a lot of host information being processed.
Down here, the attack mapping tables. What I did is the execution tactic that I just talked about. So using the user execution, how it works is I already showed in phase 2. Yeah, while I run Frogmon, of course, that is before creating the L1C dat file. It didn't launch anything. It requires me to manually create the L1C dat file to begin execution. The next tactic is the defense evasion. Right. So this is mainly talk about, yeah, the same thing. It requires me to create the L1C file in order to the malware to execute. Then about the persistence tactics, right? We're talking about the registry run keys, still in phase two that I use proc on. And yeah, remember when I show you about the lab analysis stop? Yes, in the properties. So there we find out that. All right, so this means that the malware config itself to auto run when user login again. And another tactic is command and control. So this is in the phase 4A, right, where I see a lot of applications saying about the win HTTP, like open connect, put a request where the malware trying to communicate with the extend domains. And in the 4B, right, I use the 64 DBG. So yeah, what I did is I have a breakpoint at the win HTTP connect. And after I inspect the memory, you can see in the screenshot above, I found the link https dangerous.url. So this confirmed that, again, the malware tries to outbound connect with HTTP communication. All right, so yes, thank you for watching.